Lesson 11.5 is the last lesson in Chapter 11, and now we're going to talk about solving rational equations. So at this point in the chapter, you've only been dealing with rational expressions. This is the first time you're actually going to have an equation. So instead of simplifying, we're solving now. I'm going to walk you through example 1, and then we'll write something on the left. So you're going to need to be careful for when you're looking like for a test or something, you need to be careful of the words solve versus simplify. If it's solve, you're solving the equation, you're finding an answer. If it's simplifying, you're just simplifying it to its simplest form, but you're not actually solving for anything. Example 1, 1 over 2x plus 3 over 10 equals 1 over 5x. So you're actually going to solve this just like you would solve pretty much any other fraction equation. Only difference is that your variable is in your denominator there. So what you want to look for is your least common multiple or your least common denominator, and then you're going to do a fraction buster just like we learned earlier in the year. So you're going to look for the LCM of all your denominators, 2x, 10, and 5x. You're looking at every single term that has a fraction in that whole equation. Only the ones that have fractions, which in this case all three do. So any fraction, you're looking at the denominator, no matter which side it's on. So if you're looking for your LCM, you're just going to look at your numbers first. So first number 2, 10, and 5 are all going to multiply to b, would be 10. And then you're going to always look for your variable that is the highest for these. So x is your highest variable. Now you're going to use a fraction buster, and when you use your fraction buster, you're just going to multiply each term in the whole equation, whether it has a fraction or not, every single term in the equation by this LCM that you found. So I have 1 over 2x plus 3 over 10 equals 1 over 5x. And I left a little bit of space so that I can multiply this by 10x, this by 10x, and this by 10x. Each term multiplied by 10x. We aren't converting each fraction individually to a common denominator like we would have to if we were adding or subtracting these expressions, because we have an equation. And remember, when we have an equation, we can multiply every term by a number. As long as we multiply every term, we haven't really changed that equation. It just looks different, but the value in the end is the same. So fraction buster versus finding a common denominator. That's your difference there. Okay, now you're going to simplify each individually. So 2 goes into 2 once, and 2 goes into 10 5 times, and then the x and the x cancel there. So this first term just becomes 5. 10 cancels, those become a 1. You have 3 times x, which is plus 3x. Bring down your equals sign. 5 goes into 5 once, 5 goes into 10 twice, your x's cancel. So you have 1 times 2, which is 2. Now you have a really nice, easy equation to solve. So once you find the correct denominator, the LCM for your denominators, this actually should become a pretty easy equation to solve. So now you just solve for x like you would, just isolate your variable. So I'm going to subtract 5 from both sides, and I have 3x equals negative 3, divide by 3, and x equals negative 1. And then of course, if you're ever unsure of a step that you made in here, you can always check this by plugging negative 1 in for x, In this case, you'd have to plug in -1, and then you'd either have to use a fraction buster to see if they balance out, or you'd have to actually find a common denominator on the left and then simplify it, see if you get the same answer. So I'm going to go ahead and show you that checking step just so you can see. If you weren't sure, you can go ahead and check it. So you're just going to plug in -1 for x. So we have 1 over 2 times the -1 plus 3 over 10 equals 1 over 5 times the -1. So you end up with a -1/2 plus 3/10 equals -1/5. And then if you wanted to, you could just go ahead and find a common denominator here because it's pretty easy. Your common denominator is 10. So you would multiply this fraction by 5 over 5. And you would multiply this fraction by 2 over 2 to get to 10. You'd have a negative still. So -5 over 10 plus 3 over 10 equals a -2 over 10. And then when you combine these, you get -2 over 10 equals -2 over 10. So they balance out, which means you were right. Okay, let's write a little bit on the left. So, when you're solving rational equations, you're going to use fraction busters. That's your easiest way. Remember, when you use a fraction buster, you're going to find the LCM, least common multiple, of the denominators. Of all denominators. Doesn't matter which part of the equation they're in, you still need to find them. Don't forget variables when you're looking for that LCM. And remember, your variable is the highest exponent value. So the highest exponent value of that variable, whatever variable you're looking at, is your LCM of it. And a quick little example of that is if I had x squared and x to the 4th. Oh, let's make this a 1 over x squared and 1 over x to the 4th. Typically, I wouldn't write my fractions like that, so put yours in correctly if you want to. What you're looking at here is x squared and x to the 4th, so the LCM is x to the 4th. It's the one that's higher, because I can multiply x squared by a number, or by x squared, to get to x to the 4th. I'm not going to multiply x to the 4th by something to get to x squared. And then the biggest thing you really need to remember is that an LCM is a multiple, not a factor. Okay, they are multiples, not factors. So be very, very careful about that when you're making your decision. We're so used to finding common factors. But you need to think up. It should be the highest number or above it. It should not be the lowest number when you're looking at them. So an example of that, just to remind yourself, the LCM of 10 and 5 is 10. Okay, it's not 5. The factor of 10 and 5 would be 5, but we're looking for a multiple, something they both multiply to be. Now we're going to look at another example. This is example 2. Solve 5 over x squared, which is equal to 6 over x subtracting 1. So again, the first thing you want to do is first you recognize that it's asking you to solve, not simplify. Because it's asking me to solve and I've got fractions, I'm going to use a fraction buster. So my LCM, I'm just looking at all denominators. So of x squared and x is, hopefully most of you figured out that it's x squared. So because it's x squared, I'm going to go ahead and I'm going to multiply every single term by x squared. Do not forget about your integers also. So I'm multiplying x squared here, an x squared here, and an x squared there. 3 terms, so 3 times I'm going to multiply it. Okay, in this case, my x squareds right here are just going to go ahead and cancel. X squared becomes a 1. So I just bring down 5. Equals, 1x cancels, I have 1 left over at the top, so 6x minus x squared. Do you notice what you have now? Hopefully you notice that you have a trinomial if you were to put this in standard form. You have a quadratic because you have an x squared and an x, and then you also have a constant. So from here, I'm sure you've already figured out that in order to solve, you're probably going to have to factor. And because you have an x squared, you're most likely going to have 2 answers in the end. So go ahead and put this in standard form. So now put in standard form and factor to solve. If this wasn't factorable, which I'm pretty sure almost every problem you're going to come across in this particular lesson is going to be factorable when you have an x squared. So you should be able to use factoring. But just in case, if you ever come across something like this and you're having trouble factoring it, remember you can always go back to some of the other ways that we've learned. Completing the square, quadratic formula. So you can think about those if you needed to also. So when we write this in standard form, I'm actually going to go ahead and move my negative x squared to the left because I don't like negatives in front of my x squareds. So when I have the choice, even though it means moving 2 things over, I'd rather move these over and have a positive x squared. So I'm going to move that over and I get x squared, and I'm going to move 6x over and I get negative 6x. 5 stays on the left, equals 0. Now, some of you might be using the shortcut at this point. If you're using the shortcut, you only have to look at the diamond. If you're not using the shortcut, then go ahead and do your diamond and your rectangle right now, and you should get to the same answers that I'm going to get to. So if you understand the shortcut, follow along with me. If you don't, hit pause right now, do the diamond and rectangle, and then when you're done, come back, hit unpause it, and check and make sure you did it correctly. So if you're using the shortcut, you see no coefficient in front of the x squared, so you know you're going to have 2 sets of parentheses. And you're looking at what's going to multiply to be a positive 5 and add to be a negative 6. Because you're multiplying to get a positive and adding to get a negative, you know that you need 2 negatives. You know you're going to have x here and x here. And now you're going to go ahead and look what multiplied to be 5 and added to be negative 6. And you should have had a negative 5 and a negative 1. And now you can check it. X times x is x squared, negative 1x, negative 5x. Add those, you get negative 6x and a positive 5. Okay, you're not done yet. Now you need to use the zero product property to solve for the two possible solutions. Remember, your solutions aren't just right here. You actually have to set each binomial factor equal to 0 and find the two solutions. So the first solution, x minus 5 equals 0, and then the second solution, x minus 1 equals 0, and you have x equals 5 and x equals 1. And then you can go ahead and check both of these. So when I go to check them, I'm going to check x equals 5 first. So I go to my original equation they gave me, which was 5 over 5 squared equals 6 over 5 minus 1. I end up with 5 over 25 equals 6 over 5 minus 1. And in this case, if you wanted, you could do a fraction buster. Last time I actually showed you finding a common denominator. This time I'll show you the fraction buster. Your LCM for 5 and 25, you're only looking at your denominators, is 25, but you're going to multiply 25 3 times. 25 here, 25 here, and 25 there. Remember, 1 to each term. 25's cancel, and I have a 5. 5 cancels, and I have a 5 up here, and I get equals 30 minus 25. 5 equals 5, so 5 was a solution. Now we're going to check x equals 1. So same thing, 5 over 1 squared, which is 1, equals 6 over 5 minus 1. So we can go ahead, if you wanted to, and do a fraction buster, which would be 5, 5, and 5. Oops, I'm sorry, why did I say 6 over 5? Ignore that. That was over x, sorry. 6 over 1, sorry. So this is easy, because now we just have 5 equals 6 minus 1, and 5 equals 5, so it was a solution. If you're using the shortcut, be really careful with these signs, with positives and negatives. Sometimes you might want to actually just set up at least the diamond to make sure that you get the signs correctly. So if you're a little bit unsure and you're thinking, okay, I kind of know the shortcut, but I'm worried I'm making a mistake, then what you could have done right here for your diamond is you could have just set up the diamond, and you would have had 5x squared and a negative 6x, and then you would have known negative, negative, looked for your answers, and you would have come up with the negative 5x and the negative 1x, and then this number and this number are right there at the end of your binomials, and the x is at the front. So you don't have to use the rectangle, but you can still use the diamond to help you get all the signs correct. Alright, let's write a little bit on the left. So, when you have x squared and x, you're most likely going to end up with a trinomial. You're still going to use a fraction buster. But then you're going to move terms to get standard form. So it should be set equal to 0. And then you're going to factor and solve. And remember, usually 2 answers when you see an x squared. Not always, but usually. And then always check answers. Okay, the next example is 2b. It's still part of example 2. I just want to give you one more example of these types of problems. It's kind of like what I said before with some of the other lessons. There's so many different variations that I could have you watch my notes for an hour and show you different variations, but you just have to follow the main rules, that you're looking for factoring, however you've learned to factor, and then you're solving and using fraction busters and finding LCMs and all that. X minus 2 equals 8 minus 2x over x minus 1. So in this case, your LCM that you're going to multiply both sides by is x minus 1. Because it's your denominator, it's the only denominator you have. And you need to think of these as binomials. So if you need to, put parentheses around them. Your LCM is x minus 1. So you're going to take that original equation that you had, x minus 2 equals 8 minus 2x over x minus 1. Notice I put parentheses around all my binomials. And you're going to multiply each term by x minus 1. So this side by x minus 1. And then over here I have a term in the sense that it's a binomial. But that's one piece together. So I'm multiplying that by x minus 1. I'm multiplying this piece by x minus 1. It's a little tricky because these are kind of combined terms there. But what you find is that these x minus 1's cancel. So you did exactly what you needed to, which is get x out of the denominator. And now you should all remember how to do that. If you want to keep parentheses around the 8 minus 2x, you can. Doesn't matter. Hopefully you all know to multiply here. 2 ways you can multiply. You can do the rectangle or you can just FOIL. I'm going to go ahead and do the rectangle because some of you are getting confused about when to put the terms on the inside and when to put them on the outside. When you're multiplying, your binomials go on the outside, and you're trying to find that trinomial that goes in the inside that adds up the middle terms. When you're factoring and you have a diamond and a rectangle, that's when the 4 terms go in and you pull out the binomials. So in this case, we're putting them on the outside and we're multiplying it. And I get x squared minus x minus 2x plus 2. So when I rewrite that, now I have x squared minus 3x plus 2. Remember, negative 2x and a negative 1x, I add. If you had used FOIL, you would have had x times x is x squared. X times a negative 2 is a negative 2x. Negative 1 times x is a negative 1x. Negative 1 times negative 2 is a positive 2. So you would have the same answer if you used FOIL. Equals 8 minus 2x. Based on what you already know, I have a feeling some of you have an idea of what you should probably do here. Hopefully you thought to yourself, standard form. So you're going to go ahead and get this in standard form. And once you move the positive 2x and the negative 8 over, then standard form is always going to equal 0. And your standard form in this case, once you move everything over, is x squared minus x minus 6 equals 0. Now you do exactly what we did in the last example, which is factor and solve, using the zero product property once you've factored. Again, I'm going to go ahead and use the shortcut here because I have no a, but I'm going to use the shortcut at least just with the diamond so you kind of see it. So I have a negative 6x squared and a negative 1x. Because I have a negative, I know I need one positive, one negative. And most of you probably came up with 3x for negative and 2x for the positive. So these are going to be the numbers that are going to end up in those two binomials. Only because we don't have an a, because a is 1. If a was anything else, you'd have to move on to the rectangle from here. So now we have x plus 2 times x minus 3 equals 0. Remember, you're setting each of them individually equal to 0. And you have x equals negative 2 and x equals a positive 3. I'm going to go ahead and check these on the left side just because I'm out of room. Remember, always check. So first I'm going to check negative 2. So I end up with a negative 2 minus 2 equals 8 minus 2 times 2 over 2 minus 1. 2 minus 2 is a negative 4 equals 8 minus 4 is 4 over 2 minus 1 is 1. And when you look, negative 4 does not equal 4. So this is one of those extraneous solutions. And if you notice, in the original equation, did we have any x squareds? We didn't. And so the reason you could have an extraneous solution is because when you multiplied by that x minus 1, that's when you got that x squared. So that solution looks like it's going to work, but when you actually go to plug it back in, it does not work. And then let's just check 3 to make sure. So we have 3 minus 2 equals 8 minus, I'm going to go ahead and multiply it and say 2 times 3 is 6, over 3 minus 1. And we end up with 1 equals 2 over 2, and 1 does equal 1. So your correct solution was 3. So the solution is x equals 3. And then if you needed to know the extraneous, which is the one that we got that doesn't work once we plug it in, solution is x equals negative 2. So it's not actually a solution there. So go ahead and just make yourself a little note. LCM can be a binomial. Distribute correctly when multiplying binomials. Okay, make sure you're using either the rectangle or FOIL. And if you don't know what we did there, make yourself a little note that we multiplied. example 3 is a new type of word problem. This is example 3, and it's called a work word problem. And you are going to see these on your test, and you will see it on your final, also your proficiency exam. So you want to memorize how to set these up. Go ahead and write this problem out. It doesn't take that long, and it'll help you to look at it later. It says Max can wash a car in 60 minutes. His older sister, Kayla, so I'm just going to put Kayla. Kayla can wash the same car or do the same job in 45 minutes. And then they want to know how long will it take if they wash the car together. So in this case, you can really come up with any variable you want. You can just use x because you're used to using x. You could use t for time, m for minutes if you're talking about minutes. Lots of different variables you can use that you can choose from. I'm going to go ahead and use t for time. So I'm just going to put t equals time. Okay, if they're doing it together, you need to think about what operation you'd be using. And you should be thinking about time being added to equal a total time. So it's Max plus Kayla is going to equal time together. So Max's time plus Kayla's time equals their time together. And we're looking at one job, one car washed in that time. So you need to think about that as you're setting it up. Okay, so if you stop and think about this, Max can wash the car in 60 minutes. So he's going to be working for that one car that's being washed. One car, he's going to be working 60 minutes. We're going to add Kayla's one car being washed every 45 minutes. And when we add those together, we're going to get one car washed, but we don't know how many minutes it's going to take. So that's our T. Okay, these are going to be set up this way every single time. So whatever worked together gets added to the time together. The only difference that you might see is that there might be times where they give you maybe Max's time and their time together, and then Kayla's time would be a T. But you're going to set these problems up the exact same way every single time. Only thing you have to look for is where the missing number is going to go, and that's going to be your variable. So now you've got fractions, so you're going to look for your LCM. And your LCM is going to have a T for sure. And then you also have to think of the first number 45 and 60 go into. So I usually would count by something like 45s because they're harder to look at. So 45, no. 90, no. And then I would add again. 135, no. And then I would add again. 180. 60 goes into 180. 45 goes into 180. So I have 180 T is what I want to multiply each term by. So now I'm going to multiply, I'll actually go ahead and rewrite the equation again just so you see the steps. 1 over 60 plus 1 over 45 equals 1 over t. And now I'm going to multiply by 180t and 180t and 180t. Remember every term. 60 simplifies to a 3t. 45 simplifies to a 4t. Now you're going to go ahead and multiply across. Don't forget these t's also simplify. So 3t times 1 is 3t. 1 times 4t is 4t. And 180 times 1 is 180. Now you've got a nice simple equation to solve. 7t equals 180. Divide by 7. And t equals 25 and 5 over 7, or 180 over 7. So if it's going to take them about 25 and 5/7 minutes, you're just going to round that out, and you're going to say it will take them about 26 minutes working together. So you can always round those minutes when they're like that. Okay, there's one other way that you can set these up. If you had trouble understanding how I set that up, I'm going to show you the other way that you can set these up. You'll still get the same answer. It's up to you which way you want to use. We're going to use the exact same problem. So this is just the other way. It said that Max can do the job in 60 minutes. So he is going to be doing 1/60th of the time they're going to work together. Kayla's going to be doing 1/45th of the time they work together. And that's going to total 1 whole car. Now you're still going to have a fraction buster, and if you notice, your fraction buster doesn't include the t anymore because the t actually would be up at the top of the fractions here because it's multiplying, it's a t over 1. So your LCM here is 180. You just don't have that t anymore. But when you multiply by 180, 60 cancels, 180 becomes a 3. 45 cancels, 180 becomes a 4. And if you notice, you still have 3t plus 4t equals 180. And you would still solve the same exact way from there. So it's really preference, what you see as easier. Do you want to look at it as 1 whole car, 60 minutes, 1 whole car, 45 minutes, 1 whole car, how much time together on the other one? Or do you want to look at it as this person's doing 1/60th of the time plus this person's doing 1/45th of the time equals 1 whole time? Example 4 is a proportion. It's a rational proportion. And for some reason, proportions tend to cause problems, but they really should be pretty easy. So it's asking you to solve 2 over x equals 1 over x plus 4. You could actually do a fraction buster here if you wanted, but your LCM is going to be difficult because it's going to be an x times x plus 4. So proportions, you can do fraction busters, but in reality, because I just have one fraction equal to another fraction, no other integers or numbers or anything else in there, what's going to end up happening is if I wanted to move that x, I would end up multiplying both sides by x. And I'd end up multiplying x times 1 anyway. If I wanted to move x plus 4 out of this denominator, I'd end up multiplying both sides by x plus 4, which would mean 2 would end up being multiplied by x plus 4. That's why we can use cross multiplication when we have a proportion, when there's an equals sign here, not a times. Now you just multiply. X times 1 is 1x, and then you have 2 times x plus 4. So x equals 2x plus 8. Subtract 2x. You get a negative x equals 8. And then divide by the negative, and x equals negative 8. And if you check it, you'd notice you'd have a negative 1/4 here, and then a negative 8 plus 4 would be a negative 4, so negative 1/4 there. So you're checking and it's true. The last example is just another proportion. But it's one that's got some binomials, so you're just going to have to be more careful. So it asks you to solve a negative 2 over x minus 2 equals x minus 4 over x squared minus 4. So again, you have a proportion. So you're just going to go ahead and cross multiply. But when you cross multiply, monomials need to be distributed to binomials. Binomials need to be multiplied using FOIL or a rectangle. So I end up with a negative 2 times x squared minus 4 equals x minus 2 times x minus 4. From here, you're going to go ahead and multiply everything out. So I get a negative 2x squared plus 8 equals, and then I'm going to use FOIL in this case, and I get x squared minus 4x minus 2x plus 8. Now it looks like I'm probably going to have a trinomial once I combine things. So I'm going to go ahead, combine these like terms, and I get minus 6x plus 8. Now, I'm looking at my x squareds because I don't like to have a negative. And when I look at my x squareds here, I notice that if I move 2x over, I have positive x squareds. If I was to move the negative or the x squared over, I'd have a negative x squared in there. So I want positive. I'm going to move everything to the right this time. So I'm going to add 2x squared and add 2x squared, and I'm going to subtract 8 and subtract 8. So I went ahead and did everything at the same time. I should have 0 on the left, and then I end up with a 3x squared, subtracting 6x, and my 8's cancel and become 0. So this time I didn't end up with a trinomial that I needed to factor. I ended up with a binomial that I needed to factor. So you're just going to follow the rules of factoring just like you know. 0 equals, I have a common factor of 3x, and then I have x minus 2 left over. 3x times x is 3x squared. 3x times a negative 2 is a negative 6x. You should always be able to do that. Now you set them each equal to 0 and solve. So 3x equals 0, divide by 3, and x equals 0. That should always be 0. Remember, if there was no x here, that 3 would just kind of go away because 0 isn't going to equal 3. But because we have an x, we can solve. And then we're going to take x minus 2 and set that equal to 0, and we get x equals 2. Now, your original equation did have an x squared. So there's a chance that maybe both of these work. But you need to check them because there's a chance that they don't work. So go ahead and try 0 first. So we're going to check x equals 0. So I have a negative 2 over 0 minus 2, which is a negative 2, equals 0 minus 4 is a negative 4 over 0 minus 4 is a negative 4. So these all just become 1 equals 1. So that one is true. Now I'm going to try x equals 2. So I end up with a negative 2 over 2 minus 2 equals 2 minus 4 over 2 squared minus 4. I get negative 2 over 0 equals negative 2 over 0. Okay, this matches, but if you notice, when it matches up, you have zeros in your denominator. So what would that be called? You should see that and think undefined. So this solution actually does not work because when you plug it back in, you get a 0 in your denominator, and you cannot have a 0 in the denominator. So tomorrow we'll practice more of these. There's a lot of different variations. You just have to keep practicing finding those LCMs and then being careful with your monomials versus binomials and factoring and all that stuff.